Hi, my name is Kate Chapman and this is my Lab 5 presentation. So just an introduction, the goal of this lab was to explore the interactions between a bar magnet and an aluminum foil tube. And so we're going to be looking at the currents induced by Faraday's law. And so basically what we're doing is we're dropping a bar magnet down the length of an aluminum tube, and we are calculating how long it takes for it to fall, and based on that we are able to figure out the force exerted by the rings on the bar magnet and the induced current. So the length of my aluminum tube is 0.26 meters, and the width of the foil was about exactly 1 centimeter, with the outer radius being 2.5 centimeters. And then the recorded times I have here, you can see they kind of vary between 2.72 being the largest and 1.52 seconds being the smallest, but the average ends up right around 1.94 seconds. So this is my code, and so we just start with physical constants, and we go into the making the parameters of the simulation and creating the aluminum tube. And we continue by using our Lab 3 code to make the magnetic field of the bar magnet. And then we continue to make a new function to calculate the magnetic flux. And then from there we do a simulation loop, and we walk through making the gravitational force on the magnet and then calculating the magnetic force from the tube on the magnet. And then we compute a typical B field at each ring, because we've broken down the tube into a set of rings. And from there we calculate the net force on the magnet by adding together the magnetic force and the gravitational force. And from that we get this plot, which basically shows my velocity over time and how it is speeding up, but then once it hits the tube, it basically loses any acceleration and drops at a constant rate. So, yep. Questions: why can't we use a Ferris tube? Example, a steel pipe. Because they are magnetic and there wouldn't be a magnetic current induced. What happens to the magnet? So this is Lenz's law, and so as the magnet falls through the aluminum foil tube, it induces an electric field, and then this electric field causes a magnetic field in the opposite direction of the magnet's velocity, slowing down the speed of the magnet. How does this compare to a magnet falling in free space without a tube? Well, basically, as I said in the previous question, the magnet's going to fall slower with that tube as opposed to without it. So yeah, thanks for watching. This is my Lab 5.